वह फिर दरवाजे पर Hi everyone, am I audible? Please confirm in the chat. Okay, thank you. So welcome you all to contact session 3, and today we're going to start with the virtualization. Last session we stopped, we completed till pass, I think. Try to cover that. Yes. So I'm sharing my screen. So if you're not able to see my screen, please let me know. So 3 service models we have already seen: infrastructure and PaaS. So PaaS, platform as a service, example, you could see Google App Engine. It provides Google SDK, which is software development kit on as a web application. So using that, we can build websites, host websites. Okay, here the underlying infrastructure is not managed by the customer, like choosing OS or choosing what is that? Just they'll select the hardware alone will be chosen, like based on the application. So the architecture comes like this. If you see platform, they give you the runtime environment. On top of that, you can have any APIs with respect to what language you want to build or what language you want to use, build any application. And the respect to development tools. So this gives you runtime environment, which is again collection of various software services for you to build applications where it is uh, supported by a lot of libraries. So here also, if you see common properties which we saw in the previous session, like manageability, interoperability, those 4 things: performance and optimization, availability and reliability, and scalability and elasticity. So see what services providers, they provide IDE. So integrated development environment where you'll have, like, it has full functionalities which supports underlying runtime. Let's say you want to build your runtime on Java, your application will run only on Java. You can choose that runtime. Whereas if you have a .NET infrastructure, you want a Python, which needs to be as your compiler or interpreter, you can select those environment on top of the IDE you have. Okay, it is like your Visual Studio Code or something like that, which you select in online and you go and do any coding, right? Similarly, here using this platform as a service, you can host or build applications on top of it. So this programming APIs, whichever is applicable, um, or it is even for the runtime environment, it differs, or it differs from various cloud providers. But they will use some common operating procedures, like they'll use computation, storage, and communication. All these three things will be common if you take any cloud provider. So next is your system control interface, where We'll see about so policy-based control and workflow control. So policy-based control means like the rules, okay, to take decisions and to achieve outcomes. So based on the requirement, what kind of policy you're going to use. Okay, next is workflow control. Here, flow of installation, configuration of resources based on your environment. Okay, so there is a workflow process daemon, okay, which will be there. So which will deliver the construction and management of cloud resources. So summary with respect to PaaS. So it is like it is abstracting the infrastructure, whereas it gives you development platform. Okay, which will have operating system and whatever middleware drivers for the developer is required. So PaaS provides services like programming ID and system control interface. Next is your SaaS model, the last one under the service models. Like you can see SaaS. So all your Google apps are SaaS. Okay, Google Docs, Google Worksheet, okay, Google Presentation, whatever it is. So Salesforce.com also provides SaaS products. Even Zoho provides SaaS product. Okay, like Zoho, Word, or like that only they started building products and they brought into. You can directly, if your local machine doesn't have an Excel file to be loaded, like you can take it from the internet and use such things. Okay, so here the consumer does not manage or control any underlying cloud. Okay, you can see anything like network, servers, OS, storage, etc. Okay, even the storage, they don't know how much they're using. So whatever they are loading onto the cloud, it will be working fine, and you will be getting those. You can modify the file in the cloud itself. So mostly using thin client or web-based infrastructure, you can access those applications. So you can see in this diagram. So web-based application is accessed via web portal. Okay, so any applications you can see over here. So how this is enabled through a concept called web service. Okay, so anywhere the application will be running, let's say a weather forecasting infrastructure is managed by some organization. Through web as a service, like they will get the tokens and they will be integrating any application. Even if you see, you can integrate Google Maps into your website, how it was done. So it's a service which is already available in the market. So using those links, you can directly embed that into your application. Similarly, this is also kept as a service. Like you see, Google has integrated uh, Word or presentation into their Google Apps. Okay, like into initially they were into Gmail and they started providing multiple application as their as a service. So we can use it and we can just leave it as such. So see, viewing Web 2.0, where we are utilizing full potential of the web. Yeah, viewing the internet as a computing platform and running interactive applications through web server. Even if you see, we can log in VMs through web server. That is your web application. And leveraging internet connectivity and mobility of devices. So even effectiveness is increased over a period of time. So properties provided by the internet is accessibility and portability. So easy accessibility and anywhere, any location you can access the respective location if you have an internet. So web-based application, you could see like conventional application, they should translate their access into into a web-based platform. Okay. Now everything is accessed through web browser, even your cloud infrastructure as well. So application in different domains you can see here like general applications where you have office suite, messaging kind of an application. Business applications you can see ERP, CRM, etc. Scientific application you have simulation related applications. Government application you can see national medical system and public transportation, etc. And web portal, if you see uh, from the standard, apart from the standard search engine features, web portals offer other features like you access to email, news, information, databases, etc. So they will give you what is the way, like what feature it does is it gives you a consistent feel. Okay, if you access your web application in your mobile device or web device, okay, it feels consistent. So SaaS is a completed or finished application. They are renting it to you, okay, even customized one. So SaaS enabling technique is done through web service, as I told you, through SOAP protocol they will give. Even cross vendor, cross platform also we can do. Let's say the application is built in Python or Java, can be accessed through a .NET based web service. So next is deployment model. So four deployment models we have, primary models like you would have heard about it, like public, private, hybrid, and community. So we'll quickly get into those definitions you could see. So public, we all know, the cloud resources are hosted in a public infrastructure managed by vendors like Amazon, Google, and Azure. Okay, so they have homogeneous infrastructure, common policies, shared resources, and multi-tenant kind of an architecture. Even they have leased infrastructure or rented kind of an infrastructure. So private is that is owned by an organization. Okay, and either it is managed by the organization or by a third party. Mostly it will be in on-premise or an off-premise infra. Okay, on-premise in the sense you have to have your own space. Let's say your office in your first floor, you can set up a data center. It means on-premise. Let's say you have a data center, but you have gone to a third-party data center provider. Let's say SIFI, okay, or Reliance Jio. Okay, so they also have provide space for you to host your data center into their racks. Okay, so SIFI in Chennai, multiple locations they have racks. Even Airtel is also having a data center called Nextra. Okay, so there also we can host our workloads. So in that also multiple models we have. One is like you can, if you have a Blade server setup, you can directly shift all those things into a Geo's data center or SIFI's or SIFI data center. Okay, and then what they'll provide is they'll provide rack cooling solution, internet, networking and internet they'll provide. Rest and all, we have to go set up our infrastructure in that location and configure all the network components and try to access through internet. So same firewall, whatever network components we had in our organization, instead of spending space and cooling capacity, backup features, we can take that as a rent. That is what is your it is managed by us. So always it is referred to as internal cloud or on-premise. or a private cloud. Okay, so cloud in the sense like your data center itself will be modified into a cloud infrastructure kind of a kind of thing, and you will be managing from a remote infrastructure. So characteristics, they are heterogeneous, they are customized and tailored with policies and dedicated resources, in-house infrastructure, and they have end-to-end control. Now you can see some comparison between. Okay, so homogeneous, heterogeneous policy are commonly defined. Here it is customized and tailored. So resource model is shared and multi-tenant. So they'll be consolidating a lot of servers together, and it will be provided as a shared one. And it is multi-tenant. Here it is dedicated, like single tenant. And cost is it is operational expenditure, where here it is capital expenditure. And economic model, if you see the large economy of scale, here it is end-to-end control. So next is the community cloud. So you can see from the diagram, like several organizations, they'll be contributing to some particular solution. Okay, they form them as a community. Okay, they shared things among themselves. Let's say education. Okay, so two universities, they want to have a common data to be shared among themselves, or a single university itself is having multiple locations. Okay, there they want to have certain data, like where the data are related to their community. Okay, so education. So that's it. That kind of a cloud is called as community cloud. So they will have their own mission, security requirements, compliance, and policies. Hybrid is like combination of both private and public. You see, you have a fintech, they will not keep all the infrastructure in public. Okay, they will be having certain important documents in private. It is like an on-premise data center, and also from there they will communicate to cloud for other work. Okay, which is not that much security standard they needed. So you can see the composition of two or more clouds. Let's say it could be a community or a public or private or public. Okay, they bound together. They have their own standards and properties. So now you can see the cloud ecosystem where based on the models and services. So you can see SaaS application list over here and the PaaS as well as your IaaS. So now we have a brief idea about what is cloud computing and how the paradigm shift from classic to cloud. Various service models, how you can run fundamental computing resources, deploy and develop customer related applications on cloud. Some of the references. Now we are moving on to the context session 3, which is virtualization. Hope the presentation is visible. So today's session, we're going to start with introduction of virtualization and what are the various types of virtualization we have. We're going to see in detail. So virtualization in cloud, okay, like uh, cloud itself is a virtualized infrastructure. Even we can do virtualization on cloud as well. Like you can procure infra from the cloud and you can install your virtualization on top of it. Okay, that also is possible. So transforming a classic data center into a virtualized data center. So what are the it requires for you to do that? Okay, you need the you have to virtualize the core elements of the data center. Okay, on a phased approach. So core elements in the sense your compute, your storage, and your network. So all these three together you need to virtualize. Then only you will get a virtualized data center. First is compute virtualization. So what we're going to do is it is a masking technique. Okay, you're going to abstract the physical compute hardware. Okay, and enable multiple operating system to run on top of it. So usually how it will be, you'll be having a server. Okay, if you're buying a server, let's say Blade server, it will have CPUs, multiple NIC cards, random access memories, and hard drives or SAS drives, whatever it is. Okay, so it is on a single machine, and if you want to install an operating system, you can install only one operating system on top of it. Okay, so hence, and you can install one IIS and host your website inside the IIS, and you started accessing through one of the IPs. Okay, and connected to internet, and it is going to your server is accessible from outside world. Let's say like that. Okay, wherein if you see for that website, what is the size of the hard drive or the space it has taken, occupied. Okay, it is underutilized, right? Your CPU is underutilized, your memory is underutilized, and your storage is also underutilized. Okay, so here virtualization technique is like you want to run multiple operating systems on top of server. Okay, so if you're going to run multiple VMs in terms of virtual machines, so each VM will run a OS and application. Like a VM is nothing but a logical entity. It looks and behaves similar to a physical machine. So virtualization resides between the hardware and the VM. You can see in the diagram, and that virtualization layer is called as hypervisor. Okay. So now, what is the need for compute virtualization? So now you can see the difference. Like as I told you, like if you're going to use a compute part, let's say CPU, only some portion of it will be utilized by your application. Okay. Whereas the remaining one, or usually for address translation and other application requests, okay, mostly CPUs will be used for only for some period of time. Let's say your application is not being accessed in 2 to 3 minutes in between. What will happen? Your CPU will be idle. Okay. So in such cases, how to utilize it on a shared way? That is what this cloud infrastructure came into existence. Okay, so now in the difference you can see from the diagram also you can understand. So on top of the hypervisor, that is the virtualized layer, you have multiple logical VMs running. Okay, and every VM will have its own OS. Let's say it could be Windows or it could be Linux. Okay, any kind, or multiple Windows and one Linux, like that. So now you can see the difference. Like it runs only in before virtualization, it runs only one operating system permission at a given time, and the hardware and software are tightly coupled. Yeah, and this may create conflicts when multiple applications run on the same machine. So on the same OS, okay, you will be running multiple applications. So it will share the load, and it will bring down the performance. And then you will not be able to run two applications at a time. Okay, so what will happen is one you will run, after that you keep it idle. So there will be underutilization of resources, and it is inflexible and expensive as well. So for every application, you have to buy server. If you want to run an AI application with more GPU instead of having CPU, you have to buy a separate hardware. Okay, which is again will cost you. For that, you have to install operating system. On top of that, you have to install the application like that. Wherein after virtualization, it can run multiple operating system per machine concurrently. Okay, concurrently in the sense it is not 100% parallelism. A slight seconds delay will be there. Like if you start this, next second the other machine will start. Okay, so that they will not overlap with each other. Okay, then it makes OS and application independent from the hardware. It is not hardware dependent as we saw previously. So here each VM is isolated from each other. Okay, they're not tagged together, and so there isn't any conflict at all. This improves resource utilization. Pretty well, you know, right? You can utilize the RAM or storage and the CPU at a huge way. And next is offers flexible infrastructure at lower cost. Next is just check the hypervisor. It's a software which allows multiple OS to run concurrently. So it has two components. One is the OS, that is kernel, and next one is the virtual machine monitor. So the hypervisor is, you can see in the diagram, like it has kernel and VMM. So this will interact with the underlying architecture, and it will provide interface to the other VMs. You can see where VMM is present. For every logical entity VM, a VMM will be there. So now you can see the types of hypervisor. Okay. So what are the two types of hypervisor? One is bare metal hypervisor. Second one is hosted hypervisor. So bare metal hypervisor, in the sense, from the name itself, we can identify. Okay, you have a blade server. You would have seen blade servers if you are guys. You have been into any of the data center at Wipro at any case. Can I get an yes or no? Okay. Any anybody has seen how how a blade server, two servers, tower server and blade server. Tower servers will look like your desktop. Blade servers will look like a bed kind of a thing, not horizontal like a vertical kind. Sorry, a horizontal kind of thing, not a vertical one. Have you seen it? So those are blade servers. So on top of that blade server, okay, you can install hypervisors directly on the bare metal. That is what is called as bare metal. Okay. So what happens is this hypervisor gets installed on top of it, and then it will start uh, consolidating all the compute resources, whatever it has and whatever RAM it has, and everything it will virtualize for you. Okay, so it requires certified hardware in the sense your Dell, HP servers, IBM servers, etc. So next is hosted hypervisor means and it installs and runs as an application like your virtual box, right? We have virtual box. Okay, already we have this machine has a Windows operating system, and top of that you can create one virtual box. Okay, so what happens is on top of now, OS, it could be Linux or Windows. Okay, this is already my machine is already running, right? The hardware is running, and on top of you have a Windows OS. On top of that, you can install a virtual box. Okay, so you can see here in the diagram right hand side, you have an operating system, and top of that you can install. So on top of the OS, you will have multiple applications, right? Like the laptop has. And you can also have some more VMs using some Oracle VMware based VirtualBox or Oracle VirtualBox you have. So on top of that, you can install 2 or 3 VMs by hypervising. Okay. So what are the benefits of compute virtualization? So server consolidation. Server consolidation in the sense you can virtualize multiple servers together. Okay, like as you say, a single server you can run multiple OS on top of it, and you can run multiple applications. Okay. Next is isolation. Isolation in the sense you can isolate the services like from hardware and the software virtualization, right? So you can isolate the hardware from the higher level of layers, and you can use it by sharing. Next is encapsulation. Wherever encapsulation is required, you can apply. Hardware independence. So hardware is independent here and reduced cost because for single application, usually we will buy a server and use it. Now that is not required. So now we will see x86 hardware virtualization. So if you see an operating system is designed to run on a bare metal hardware, okay, to fully own the hardware, like how it will be. Like if you see user apps will be in ring 3, and the ring 0 is where your operating system is. Below that, you will have the hardware. Okay, now you're going to, uh, what is that? So your ring 0 is the operating system, which is the most privileged one. You would have studied about OS, uh, Linux VMs and all. Okay, there you will see how it is the privilege levels. Okay, so challenges of virtualizing this one. How you want to virtualize? Okay, so you need to place the virtualized layer below the ring 0. Okay, and it is difficult to capture or translate the privileged OS instructions at the runtime. So usually the OS will be tightly coupled to the hardware so that the OS drives the actual hardware. Okay. So now we are going to whatever OS wants to do from the application perspective, it will translate and give it to the hardware. Okay, under okay. So now if it is you are going to have a virtualized layer, again the same thing should happen, but how it will happen? So based on this only the techniques they have like full para and hardware assisted virtualization. So full is like you have the hypervisor in the ring 0. That is, instead of OS, you install hypervisor. On top of that, you may have multiple guest OS. And on top of that, each guest OS will have multiple application. Okay, so if you see VMM decouples guest OS from the application, sorry, from the underlying physical hardware. Okay, so each VM is assigned with a virtual machine monitor. Okay, and it provides virtual components to each VM, and also it does binary translation of non-virtualizable voice instruction. So guest OS will not know whether it is being virtualized at all. Okay, it will work like as if it is a separate OS. So para virtualization, you could see it is similar like below the what is that ring 0, you'll have the hypervisor. And on top of that, you have para virtualized guest OS. Okay, so guest OS runs in ring 0. Okay, and modifies, if you see modified guest OS kernel is used. Examples are like Linux and OpenBSD. So unmodified guest OS is not supported. So Windows will not be supported at this stage. Hardware assisted this thing is you will have hypervisor aware of CPU. Okay, on privileged instruction like you can use hypervisor itself to directly communicate. So you will have a virtual machine monitor at the bottom. Okay, and the guest OS at the ring 0. So this is done by the processors like AMD V and Intel V technologies. So virtual enabled technologies. That is, it is like the Oracle VirtualBox, right? A similar way it works. Next is the virtual machine. So we'll have a short break now and then continue. Okay, let's continue. So virtual machine, so it's a logical compute system. Okay, it runs a OS uh, and applications like a physical machine. So it will have virtual components such as CPU, RAM and disk and an NIC card. So from a hyper perspective, a VM is a discrete set of file. Okay, it's a file which is getting executable. Okay, which has a configuration file, virtual disk file, virtual BIOS file, and VM swap file and log file. So you can see what are those files. Okay, so BIOS file stores the current state of the virtual machine. Okay, in that respective file. Swap is like paging. So in Linux, you will have swap space. The pages, related files, and those backups will be stored. Okay, and whatever RAM contents in the physical memory they have, right? Those contents will be stored on the hard drive. So that's swapping. Okay, between the physical memory and the storage. So this file exists only when the VM is running. Before that, it is a VM. Who's that? Shruti, can you please mute? Go on mute. So next is your virtual disk file. Okay, in the virtual disk file, it stores the VM disk image, okay, and the contents of the file, okay, contents of the VM. It appears to be a disk drive, okay, a physical disk drive, and it can have multiple disks as well. Coming to the log file will be like access lag or activity lag, okay. So whatever VM does, okay, those logs will be generated and that will be stored inside this log. And this is useful for troubleshooting. So usually this will not be accessible to us. It will be accessible only by the vendor. If you say Microsoft Azure, they'll be holding all these things at the backend. And coming to virtual configuration file, like this is the configuration of the VM. Let's say what kind of VM we have selected. Okay, and those configurations will be stored during the creation of. Yeah. So whatever you chose, let's say 2 core 8 GB of RAM like that. So how many number of CPUs or memory and number and type of network adapters and disk types. It could be a hard drive, HDD, SSD, or premium SSD. So file system manage VM files. Okay. So what kind of file system? So file system supported by the hypervisors. Okay, are like you have a virtual machine file system, which is VMFS, and network file system. Okay, so your VMFS it's like a cluster file system that allows multiple physical machines to perform read and write on the same storage device. It means storage also they have been consolidated, and on the same storage device they will access it concurrently. Okay, so this is deployed on a fiber what is that? FC is fiber-based fiber connection, or a high SCSI storage apart from local storage. So they will drive at a very fast speed. NFS these enables storing VM files on the remote file server like NAS device. Okay, where it is done. So And then those NAS devices, those clients will be having inbuilt into hypervisor. So now you can see a virtual machine hardware. Okay. So hardware components, so virtual CPU. So it is not the actual CPU. Okay. So the actual CPU is virtualized based on the ratios. Like let's say you have a one core, your hardware, the real hardware has some 4-core CPU. So those 4 cores can be splitted again to some 2 cores. Okay, 4 2s are 8. It can be given as 8 cores to the actual virtual machines. So virtual machines can be configured with one or more virtual CPU. Okay, you can see in freeware like in one core CPU, it is like vCPU, virtual CPU. It is not a one core. In Azure, whereas in even all cloud providers, they used to give, if they say 2 vCPUs, it will be one actual CPU count, core CPU in the actual physical machine. And similarly, VRAM, you have like amount of memory presented to the guest operating system. So here also memories can be changed based on requirement. So virtual disk, if you see, it stores VM's respective OS and the application data. Okay, if you take any VM, it will have at least one virtual disk. VNIC is your virtual network card. Okay, and VDVD and CD-ROM drive. It is like on a VMware infrastructure or a VMware that is like Oracle VirtualBox. Okay, you can have install ISO images, like how you install operating system on top of that, right? You can use this maps a virtualized hard drive, sorry, a DVD drive or a CD drive kind of a thing, where you can host images and you can load. Similarly, virtual floppy drive is not being used mostly. So next is your SCSI controller, that is your SCSI controller, and to access those virtual disk, and USB controller for you to access. For example, you have attached a USB in your VM and sorry, in your laptop, and you want to access that content in your virtual machine. So that can be done. So virtual machine console, it provides mouse, keyboard, and screen functionality. And then it sends power changes on and off to a virtual machine and allows to access the BIOS of the respective VM. Okay. And typically, virtual hardware configuration troubleshooting issues, it will be like a console. Okay, where you can see a lot of VMs installed. Even you can see that on a virtual box as well. If you have 2 virtual machines, you can see not installed on this laptop. So in next session, I'll show you a demo like how this looks. Okay. Next is resource management. So resource management from the word itself, we can be able to relate that it's a process of allocating resources from virtual machine or a clustered physical machine to a VM. Okay, to optimize the utilization of resources. So what is the goal of this thing? It's like goals of resource management is to control the utilization of resources and prevents VMs from monopolizing resources, like they should not lock resources. Okay, and then allocate resources based on relative priority of VMs. So resources will be like it will be in terms of pooled. Okay, you need to manage them centrally. Next is resource pool. So again, resource pool is a logical abstraction or aggregation of physical resources. Okay, that needs to be managed centrally. So as I said, like you have to club all these hard drives and CPUs, compute, and random access memories grouped together, and from application you have to allocate them on various hosts. So this created from a physical machine or a cluster, and administrators may create child resource pool or a virtual machine from a parent resource pool. Okay, from there, this virtual machine will always, if you see your cloud, okay, you'll be having the configuration alone. Once you shut down, all your resources will be deallocated. It means that it will be released, okay? You will be having from that host until you restart the machine or you're starting the machine again, bringing the VM up. After that, your image will be loaded, that is your operating system image will be loaded, and the requested capacity for your or the allocated capacity, let's say 2 core for 4 GB of RAM and some 100 GB of drive. Okay, drive alone, disk is separate, and these two, okay, on a particular region, on the particular host, it will be getting the specified amount of CPU and specified amount of random access memory for you to run your VM. Okay, next is your reservation limit and share. So even if you see in Azure, if you are not buying a reserved instance in AWS or whatever cloud you have come across, for a particular VM, let's say 4 core 16 GB of RAM or 4 core 8 GB of RAM is required. So you can reserve it so that 24/7 your reservation will run and they'll give you some cost reduction as a discount. Whereas if you want to do auto start stop, okay, so you want to stop your VM at 12 o'clock in the midnight or 10 o'clock in the night, and later on it should auto start at 8. Okay. So what happens is once you deallocate your mission, that means you have shut down your mission. Okay. So these two resources will be released from your quota. That is called as quota. So or the limit. Okay. There isn't any reservation at all. There is you have allocated some quota for core always. So similarly, multiple vendors they'll be sharing multiple customers they'll be sharing the same host on a particular region. Okay. So these things, okay, will also have an issue. We have faced issue in region wise limitation of quota. So missions did not come up on time. So now you can see resource pool example. So standalone physical mission. Okay. So it has 3000 megahertz. So 3 gigahertz and 6 GB of RAM. So C pool is been splitted into 1 megahertz per pool for engineering, finance, and marketing. Okay. And then each engineering is again subdivided into test VM, production VM. Again, you could see finance has a test VM and production VM. So it is like 0.5 gigahertz and 1 GB of RAM. So they will give it as one virtual CPU. Okay. So share limit and reservation. As I told you, certain parameters that controls the resource consumed by the child resource pool or a virtual machine. How it is done. So if you see share means amount of CPU or memory resources a VM or a child resource pool can have with respect to its parent resource pool. From the diagram, you could see parent resource pool is having 2000 megahertz. So it can be divided into 1000 by each VM. Okay, so limit is maximum amount of CPU. You cannot go beyond that 1000, right? Okay, so or the memory where the child has to consume. So that is limited. Reservation, as I told you, amount of CPU and memory reserved for a VM, as I told you, right? So reservation is, so for this engineering pool, only you can run 2 VMs. under it. Okay, you cannot run more than that. That is a reservation. So if it is fixed, let's say the engineering test VM is fixed to run for a long period of time, since the 500 megahertz will be completely fixed for them for a period of 1 year or 3 year. It is based on the vendor. So optimizing CPU resources. So modern CPUs, it has hyper-threading, multi-cores hyper-threading. I don't think you would have seen single-core CPUs, okay, processors like Intel Xeon, a very old one. Even if you take desktop series of processors, you have computer architecture. You would have studied computer architecture paper where you will have single CPU. In the single CPU, you'll have only single core. Now, what they have done is after that, the single CPU core is divided into two cores, okay, like dual core. All your i3 processors will have dual core, okay. All your i4 processors will have, i5 processors will have four cores, okay, and your i7 will have eight cores. Okay, a portion of your single is split into eight core, and internally they do threading. Okay, threading is lightweight process. So internally hardware threading is also there. That is what they've given, equipped with multi-cores and hyper-threading. So multi-core processor means it has multiple processing units called cores in a single CPU. Hyper-threading makes physical CPU appear as two or more logical CPUs. So internally to the core also you can split based on threads. That is what all these the cloud vendors what they were doing. They use hyper-threading, and that's where they give virtual CPUs to you. So allocating a CPU resource effectively and fairly is critical. It is highly critical. And the hypervisor schedules virtual CPUs on physical CPUs. And these hypervisors support multi-core hyper-threading and CPU load balancing features to optimize CPU resources. So now the CPUs which is currently under production has load balancing itself. They automatically give or allocate resources based on the cores automatically. So you can see the diagram. So single core, dual socket, okay, and dual core, single socket. So when you can go and search in the internet, like we had process desktop based process like Pentium D. D is a dual core processor. After that, they brought in core 2 Duo. Okay, core 2 in the sense they'll have two cores, core 2. Okay, and then they add four cores, which is your i5. Okay, and internal to the cores, you have multiple threads. So hyper-threading now you can see. So makes a physical CPU appear to be two logical CPUs. Okay, so it enables OS to schedule two or more threads simultaneously. Okay, as they have two CPUs, right? So they will run for each CPU or CPU core will have two threads. So four threads they will use. So four processes they can execute concurrently. So two LCPUs will share same physical resource. While the current thread is stalled means stopped. Okay, it is being idle or it is given to some process. CPU can execute another thread. So it is not like it is attached. So it will resume some other time based on the thread in a life cycle. Yeah. So hypervisor running on the hyper-threading enabled CPU provides even more improvised performance and utilization as they are into shared kind of a thing. Okay. So next is optimizing memory resource. Like here we are moving from CPU to memory, your random access memory. So hypervisor will manage the physical memory. Okay, so part of this memory is used by hypervisor and rest will be given to virtual machines. So VM can be configured with more memory, okay, than physical memory available. As I said, right? It can give memory over commitment. Yeah. Like if you're, it can even give more than 256 GB. Okay, so optimization is done to allow over commitment. Let's say if it is your process requires more random access memory, at that time it will provide unless other CPUs are being idle in that host. Okay. So memory management techniques are like the transparent page sharing, memory ballooning, and memory swapping. So let's see memory ballooning. Let's see what is the time. Yeah. So we'll stop here, or else we'll complete this alone. So we see no memory shortage balloon remains uninflated. Okay. So whenever a guest OS requires memory, okay, what happens is based on the demand of the OS is being executed. So what it does is it will force a page out. Okay. So when the memory is being utilized more, and then what happens is it will move the data to the page out means it will move the data to the hard drive. Okay, so hypervisor reclaims the memory. Okay, so that reclaims in the sense it will give memory to another process. So at the same time, you can see memory shortage is resolved. Okay, after that, it deflates the balloon. So that guest OS can use pages accordingly. That concept is called as memory ballooning. Memory swapping is every time when you switch on your VM, okay, it will bring in and bring out. It is like send it out and send it back. So created when a VM is powered on, okay, and deleted when the VM is powered off. Swaps file size is equal to the difference between the memory limit and the virtual memory reservation. So what it will do is when you want your VM to be up and running, you need the swap space, right? So once you shut down your VM, the swaps file content will be removed. So hypervisor, what they do is they swap out the VM's memory content if the memory is scarce. Okay, and swapping is the last option because it causes notable performance impact. If you are not swapping, what happens? The CPU or your processor will go, your speed will reduce. So this conversion we will see in the next session. Okay. Any doubts? Guys, please check whether you are able to see the CC quiz 2 and you can take it for now for this session. So if you completed the quiz, you can leave.